So you might have come here from the other video about why you need to have a geotechnical investigation for your house, but if not, I'm just going to talk about percolation tests and the disposal of effluent on your site if you're not connected into the municipal sewer system. So the SAN, South African National Standards 10400 specifications in terms of disposing of effluent on a site. So if you don't have access to the municipal sewer system, you're going to have to get rid of your sewage one way or the other. So one thing you don't want to have to do is to install a conservancy tank. So essentially a conservancy tank is that all your sewage goes into the tank, a sealed tank, and then you pay these, what they call the honeysuckers. They come around and pump it out once a week or whatever when it reaches a certain level. So that's an ongoing maintenance cost and you don't really want to have that. So first prize is to connect to the municipal sewer system, but second prize obviously is to install a septic tank system. So what it entails is the septic tank, which is downslope of the house. So your sewer line or sewer lines run into the septic tank. It's normally 3 chambers. They're kind of separated from one another. So there's some aerobic digestion of the sewage, and then once it gets through to the 3rd chamber, it gets directed into a soakaway or a French drain. So we can design all of those aspects of your system, but before we do that, we have to do what's called a percolation test. So it essentially entails, and we'll do at least two on your site. If it's a bigger site, we'll do as many as we think is necessary, but at least 2 so we can at least get an average result. So we dig a hole, 2 holes. Well, I'll just talk about a specific test. So it's probably a 1 meter by 1 meter by, if possible, 1 meter deep, maybe minimum 700 deep hole. And in one corner, we'll dig a sump, a 30 centimeter by 30 centimeter by 30 centimeter sump, and we'll soak that sump for 4 hours. And then we'll put a ruler or a tape measure in that hole, and we'll run a stopwatch and measure the fall of water in that sump over a period of 30 minutes. So we'll take a reading every 5 minutes. So it starts with 0, 5, 10, 15, 20, 25, 30 minutes. And the whole aim is to get a fall in water of at least 25 millimeters, 1 inch. So, and I think the tests were originally set up like that. At least 1 inch fall over a 30-minute period, or 2.5 centimeters, 25 millimeters. So if it doesn't pass, if we don't get a 25 millimeter fall over that 30-minute period, we have to go to plan B, and that might mean, and I don't want to get ahead of myself here, building an evapotranspiration bed or possibly installing a conservancy tank, which I spoke about a little earlier. So we don't want to go there. So we'll run the test. If it passes, hallelujah, and then we can design the system. Once you plot up the data, and I'm not going to get into that right now, you can come up with a percolation rate. And based on that percolation rate, you can work out the rate of application of effluent to the sidewalls of your soakaway, your French drain, in liters per meter square of sidewall per day. And that's based on the percolation rate. So if it's not a great percolation rate, you need a bigger area. And if it's a good one, well, then you don't need such a great area. So in terms of designing the French drain or the soakaway, it's not about digging a huge hole. It's about surface area. So you can dig a narrow trench, maybe with a TLB, JCB backhoe. And so there's an upstream side and a downstream side, so to speak, and that can be your surface area. And you don't actually include the base of the trench for the excavation, because that soon gets, sealed off with fatty acids and other gunk that comes in from the effluent that's coming out of the septic tanks. So it's all about sidewalls, and you leave the base out. So there's no point digging a huge hole with a big surface area of the base, because that's going to not provide you with any additional soakaway surface area over the longer term. Okay, so, and it's also much easier if you have a narrow trench, and then it has to be backfilled with clean rubble, no cement in it, no concrete, or fist-sized stones, or just to create a voided space that the effluent can run into. So it comes through on a slotted pipe, it gets directed down the length of the trench, and the keel, the pipe slotted. I'll put a little figure up. So the pipe slotted, imagine my fingers are slotted, the effluent runs along the base of the trench, and it distributes it all the way along the length of the trench, and it overflows, it spills out through the gaps or the holes that you've drilled into the voided zone, the rock, the fist-sized rocks or the rubble, and then it soaks away into the sidewalls of the trench. So there's percolation through into the sidewalls. As the pipe runs through, imagine the pipe running towards you, it's slotted, the water runs out into the sidewalls of the trench and then out into the greater into the larger soil, the soil profile. All right, and then nature does its work. And what's the word? All those bugs and lovely creatures that live in the soil will then gobble up any other pathogens or E. coli or whatever that happens to be remaining. But it all boils down to that 25 millimeter fall and whether the soils are actually suitable for the disposal of effluent via percolation method. So if you need that, we certainly can do that. We'll send a team out there, we'll dig the holes, we'll run the tests. It takes a better part of a day, I'm afraid, because the regulations stipulate that it has to be soaked for 4 hours. So maybe an hour of digging and 4 hours of soaking and a travel time on the other side. And of course, then you have to run the tests as well, half an hour per test. And then the holes have to be backfilled and reinstated. So it is pretty much a day's work, a day's job. Okay, so we can do that. We can tack them onto the larger geotechnical investigation for your house or whatever other property you're developing. And we can also do them, if you just need the percolation test, we can certainly mobilize a team to go and do that work for you. And then of course, we'll write you a little report, mostly in the case of a percolation test, a letter report spelling out what we found and the results, which then can be used for your submission to the relevant local authorities, whoever is in charge, the statutory bodies whose officials you have to satisfy. Okay, so there you are, a little bit of a spiel, a little bit of a story about percolation tests. Nothing complicated, it's a simple thing, but actually vital because you don't want sewerage, for obvious reasons, spilling out into places, affecting your neighbours or affecting your property and all those kind of things. Oh, and before I close, also the other thing that we have to pay attention to is what's called the evapotranspiration area. So there has to be sufficient area left aside on your property so that downstream of the soakaway, where the water flows into the sidewalls, can then migrate downwards into that space, and then evaporation and transpiration from obviously plants. High water demand plants are always much better, but anything will work. You're not allowed to build on that area, and you're not allowed to gravel it or tar it or develop it in any way. No building of swimming pools or anything, so that area has to be set aside. So a lot of people don't actually pay attention to that. I remember doing a job in a very upmarket housing estate some years ago, and they built this massive house. Almost every square meter of that site was put under development. There were 2 swimming pools in the house. There was lots of bedrooms, an underground cinema, and there was no space left for the evapotranspiration area. So I'm not sure ultimately what happened with regard to that. They might have had to put in a conservancy tank, but I remember having a niggly conversation with the engineer about that whole thing. Anyway, so I tell you that story as a word of warning. You have to allow sufficient space on your site to allow for the disposal of your effluent via an evapotranspiration area. And I kind of alluded to that at the start of this little talk, because sometimes you might have to make an artificial one too, and we can design that so that we don't have to go the conservancy tank route. We actually build an artificial evapotranspiration area. And so, yeah, that's when it starts getting a little bit complicated. But hopefully on most sites they pass, and we with flying colors sometimes. But the only way to find out is to actually run the tests. There was something else I wanted to tell you, and I'm trying to think what it is. Evapotranspiration areas, obviously the percolation tests. The septic tanks, we can do the designs for. Goodness me, I thought, I must just pop that into the chat. But something fairly trivial. Oh, this is what it was. The evapotranspiration, or the size of the evapotranspiration area, is based on the estimated effluent flows from the house. And that's based on the number of bedrooms. So a 2-bedroom house obviously generates a lot less effluent than a 3-bedroom house, 4-bedroom house, 5-bedroom house. And you also have to include domestic quarters if you have those on your site, on your property. So that's another bedroom. Okay, so there you have it. The building regulations, the national standards also publish figures for estimated effluent from schools and drive-in theatres and restaurants and daycare places and factories and offices and all that kind of stuff. So if you want us to do those, because obviously you might be listening to this video and not wanting to build a house but to put up an office block or some other kind of development, then those figures then have to come into play. But it's all well documented, so we can just pull those things and work out how much effluent you're going to generate, the size of your septic tanks, the size of your soakaways, French drains, and the size of your evapotranspiration area. And if need be, we can go the extra mile in terms of, and if need be, we can do all those designs for you too. Okay, so I'm going to leave it at that. Please give this a like, give it a share if it resonated with you. I know it's a pretty boring thing and I don't really want to be known. I don't want to be vulgar about this, but it's not something we want to be known for doing. I'm a geotech guy, so we love to do slope stabilities and foundation designs and drill boreholes for roads and bridges and tunnels and dams, and I've done all those kinds of things in my time and instrumented dams, but sometimes people just need the simple things like having their sewer system designed based on the prevailing conditions downstream or downslope of their house, so we also have to do that kind of work. Okay, so I'm out of here. All right, so we look forward to maybe meeting you on site or meeting you to talk about your development needs, or maybe you just want to learn a little bit about geotechnics and these kinds of things. And if that's the case, just follow our channel here. Okay, so I'm out of here. Look after yourselves until the next one. Thank you, take care, and see you on the next one. Bye.